So we've been factoring for about a week now, and we're going to take what we've learned and we're going to extend it to something called factoring completely, because it is not something that we have really practiced very much. We factor, and we are getting very good at factoring, but we have not been factoring completely. The first thing I want you to look for, this pretty little, I apologize, this pretty little map here walks you through exactly the things you need to do every time you factor, and it's a nice little map. It shows you exactly what to do and exactly where to go. There is a copy of this on Edline if you want to go pull it and print it off. I will have a copy for you in class tomorrow for those of you that don't get a chance to do that, but you will see it walks you through. Step 1, does what you want to factor have a greatest common factor? If yes, then factor it out, and then can you factor what is left? If no, you're done. If yes, you can still factor what's left, then you go back up here and walk through. Is it a perfect square trinomial? Yes or no. Is it a difference of two squares? Yes or no. And it just step by step exactly what to do. I'm going to walk you through this, but this pretty little map is on Edline if you would like to go get it. So we're going to factor completely, and I'm going to show you, but the first thing I'm going to do is show you what it doesn't mean, because we've been factoring all along, and so y'all know what it looks like to factor. This right here, hopefully you recognize that this is a difference of two squares. And so if I'm going to factor it, my factors are going to be opposites, but it's going to be the square root of this one and the square root of this one. So the square root of x squared is x, and the square root of 25y squared is 5y. And so my two factors are x plus 5y and x minus 5y. And if you will look at what I have left, these two things do not have a greatest common factor still. They don't have anything else that can be factored out. So this is factored completely. This is what you're used to doing. What you're not used to doing is the next step that I'm going to show you. And so step 1 on that little map that it says to do is first check for a greatest common factor. So the first thing that you should always do is check to see if you have a greatest common factor. This one does happen to have a greatest common factor, but that is not where, we can start there. Greatest common factor. So this does have a greatest common factor. They both have a 3, and they both have an x squared in common. So the first thing I'm going to do is factor out a greatest common factor, and that leaves me with x squared minus 4y squared. So if I went back to that map that I showed you, it would now say, can I factor what is left? Well, this is what is left, the x squared minus 4y squared. And if you will think about the things that we have been learning, this right here in parentheses is a difference of two squares. This in parentheses can still be factored. And so I am not completely done with this problem until there is nothing left that can be factored. Everything has to be, if I still have room to factor, I've got to go ahead. So the 3x squared is still one of my factors. But then this being a difference of two squares, I have to factor it like I did this one over here. So I end up with x plus 2y. The square root of x squared is x, square root of 4y squared is 2y, and then x minus 2y. This is not necessarily incorrect, but this is not all the way done. It's like saying 2/4 and 1/2. This is much more accurate, and if you are asked to factor something completely, what you're being asked for is this answer, not the top one. So it's something you want to get into the habit of doing, because it's very important that you factor completely all the way through. We'll practice 2 more. So this right here, if you will notice, is just a perfect square trinomial. I can factor this using the box method or the AC method. But we're going to walk through what it said on that little map. And so step 1 says, is there a greatest common factor? Well, there is a greatest common factor here, because 4 will go into all of these. So the first thing I'm going to do is factor out the number 4. If I pull out a 4, then I have d squared minus 7d plus 10 left. Now this is a trinomial that can still be factored using the AC method. So I'm going to factor what's in parentheses using the AC method. The 4 gets to follow along the entire way through. It's just like when you have a negative in front, except you have a greatest common factor. So 1 times 10 is 10. I need two numbers that multiply to equal 10 that are going to add up to equal negative 7. Well, those two numbers are negative 5 and negative 2. So I'm going to rewrite this. So I have 4 times d squared minus 5d minus 2d plus 10. And then I'm going to group, like I have taught y'all, put a plus sign here, and then I'm going to group these two. Well, the greatest common factor for the first set is going to be d. Carry the 4 through, pull out a d, which leaves me with d minus 5. And then for this set of parentheses, my greatest common factor, I'm going to pull out a negative 2, which would leave me a d minus 5, because negative 2 times negative 5 is positive 10. And so now I have factored, and so my three factors really are 4, d minus 5, and d minus 2. You can factor it the other way. You can factor it using AC method, but when you get done, you're still going to have a factor that has a greatest common factor you're going to have to pull out. And so you're still going to end up with these three numbers as factors. I'll show you. If you factor this using the AC method, just plain old AC method, and you don't draw an ugly line on your board that gets in the way of everything. Let's try and draw a prettier line this time. Or let's close it all so we can't see anything. Oh, you're kidding me. Stupid shade. Okay, let's try that again. There we go. So down here, I'm going to factor it using the AC method. It's the same problem, the 4d squared minus 28d plus 40. And you're going to start by doing 4 times 40, which is 160. Well, first of all, that's a really big number I got to try and find factors of. That's the first problem with this. But I happen to know, because I've already done this problem, that the two factors are going to be negative 20 and negative 8. And so then you go ahead and you break it up to 4d squared minus 20d minus 8d plus 40. And you do your greatest common factor. So right here you pull out a 4d, leaving you with d minus 5. And here you pull out a negative 8, which leaves you with d minus 5. And so your two factors are 4d minus 8 and d minus 5, which does not look like what I wrote up here, but that's because you see this first factor, 4d minus 8? Well, 4d minus 8 has a greatest common factor of what? It's got a greatest common factor of 4, so you have to pull a 4 out of this, which leaves you with d minus 2 times d minus 5. Now this looks like that. You can still do this, doing the AC method and not having to pull out the greatest common factor first. If that is less confusing for you, do it that way, but you have to make sure that there is no factor remaining that has a greatest common factor you can pull out. So let's try the next one that I have written way up here, and I'll try not to mess it up. So 15x squared plus 3x minus 12. Step 1, is there a greatest common factor? Yes, there is they have a greatest common factor of 3. So factor out the 3 and you are left with 5x squared plus x minus 4. And we're going to factor that. What's in parentheses? 5 times negative 4 is negative 20. The two numbers that will work for me are 5 and negative 4. That's how I get negative 20. And when I add them, I get positive 1. So I'm going to factor the same way. I have 5x squared minus 4 plus 5x minus 4. I forgot my squared. And we're going to factor. So 3. Greatest common factor here is going to be an x, leaving me with 5x minus 4. And my greatest common factor here is a 1, which leaves me with 5x minus 4. So my factors are 3, x plus 1, and 5x minus 4. And like I showed you in the last problem, I'm not going to do it again because you don't need me to do every problem twice. You can do this using the AC method. However, AC method for this problem is gross because 15 and negative 12 is going to give you a really big number you have to find the factors for. If you can pull out a greatest common factor first, do. It's going to make everything easier. It's just like reducing fractions before you multiply. It makes your life easier, okay? So I'm going to make sure that this is on Edline for you to go pull off. I will also have copies for you tomorrow when you come to class so that those of you who can't print it off don't. But it's a great little map to walk you through. Step 1, do this. Now do this. Now do this. It's a great little visual for all of you. So if you want to go grab it and print it, you can. If not, I will have copies for you when you come to class tomorrow to walk you through the steps while you are practicing. And I will see you guys when you come to class.